Okay, let's take a look at homework number 16. Make sure you've got your graphing calculator ready because you're going to need it for some of these tasks. All right, the first one is basic function equality, reading from graphs. So we're going to take a look at two functions here. One of them is called f of x, and the other one is called g of x. And f of x is a quadratic, so that means it's the parabola here. And g of x is linear, so that means it's this straight line. The question at the bottom of the screen says, find the value or values of x for which f of x is equal to g of x. So the outcome of f of x, that would be the y value, is equal to the outcome of g of x, which is its y value. So when are the y values equal? Well, in order for that to happen, we need to know some of the points that they have in common. So the first thing you should be looking at are these two items right here, which are the intersection of the system. And those 2 points, which this top one here is -4, 5. And this bottom one here, which is -2, 1. Both equations, both functions, f of x and g of x, they both contain this point, meaning these values of x and y make both of the equations true. Right, so my first equation here, let me scroll up for a second, was -x squared minus 8x minus 11. So again, if I'm go back for a second, and I just look at this point here, -4, 5. If I were to substitute this value for x and that value for y in this equation, -4 squared minus 8 times -4 minus 11, it should equal y, which is 5. So the opposite of -4 squared would be -16. This one here would be +32 and minus 11. And I'm going to check here to see if that equals 5. So -16 plus 32 is 16. 16 minus 11 is 5, so it checks. If I put these same values into g of x, which was this, if I put a -4 in for x, will y be equal to 5, right? That's what we're checking. So -2 times -4 is 8, and 8 minus 3 is 5. So these two values make f of x true and g of x true, so that means they are a shared value. And what they're asking me here is, of these 2 points, -4, 5, and this point here, -2, 1, for what x values are the functions true? So we're looking just at these x values. So when x is -4, both functions intersect. And when x is 2, both functions intersect. So all you need to type in your answer box are those two values with a comma in between. So at -4, comma, -2, these two functions are the same. Let's try that one more time. All right, let's take a look at this one here. So when I look at my parabola in my straight line, I see an intersection here at -4 and an intersection here at -1. So -4, -4, comma, -1. They're going to put the curly brackets in for us. All right, whoa, look at this function. Cubic function, a little crazy, but again, we're only looking for the solutions, right? This is a different wording from the last question. Find the solutions to when f of x is equal to g of x. So we just want these 1, 2, 3 points this time. So when x is -2, comma, when x is 0, comma, and when x is 2. So this one had 3 solutions. You can have no solutions, you can have 1 solution like this one, you could have 2 solutions, 3 solutions. It depends, every situation is different. So all you have to do is look with your eyeballs, to find the solution or to find the value of x, you simply find that point of intersection, list that number, and you're done. All right, let's take a look at this one, which requires graphing technology. So let's see. Oh man, they didn't show us. They did not show us the graph. So what we're going to do is turn our graphing calculator on. We're going to press the y equals button. We are going to type our functions into y1 and y2. So let's see, we have absolute value of x plus 1. So you can use the math key or you can use the fraction button. So I'm going to go from math to number. So again, I clicked math. I clicked to the right to get to the number menu. So absolute value of x plus 1, arrow out, then a subtraction 3. My next one will be 1/5 with an x on the side, not in the bottom, plus 2. Go ahead and look at that graph. All right, yep, absolute values have a hard V shape, so I know I typed it right. And this one has a power of 1. X to the power of 1 is a linear function. I see, looks like 1, 2, 3, 4, looks like -5, and 1, 2, 3, 4, 5. Looks like -5 and +5. But you know what I'm going to do? I'm going to check my table just to be sure. So second graph, and in my table I'm going to go to -5, and you see how these y values are the same? Okay, so a value of -5 would make it true, and then I'm pretty sure I saw with my eyes that +5 was also, yep. So all I have to do is type that in here, -5, comma, +5, and submit. So for these problems without the graphs, you're going to have to turn your calculator on. You're going to have to clear out your y equals menu. You're going to have to type each function separately on their own line. 3 raised up to the power of x plus 5, and then -1/4. If you're feeling lazy, you could just put 0.25. -1/4 x plus 6. Now you can look at the graph because that'll be faster than scanning the whole table, but essentially you'll want to look at that table to look for those matching values. So I see one here at 0, but then I guess I'm curious if there's another one. But I definitely know there's one at 0. So I'm going to actually look at the graph because it makes it faster for me to know if there's more than one intersection. Nope, looks like there's just that one at 0, so I'm going to type that in. So use your graphing calculator to type each function, and then look at the graph, and then confirm by looking at the table. All right, next section, function equations using technology. So this one here, you see how this intersection point is not an integer, right? It's not a perfect corner point. So I know they showed you the graph. It's helpful because it means that there's two intersections. But what I want you to do is really concentrate on making sure you calculate both of those intersections. So look, turn my calculator on. Oops, go to my y equals button, clear everything out. I'm going to type -x², and then down here, instead of the fraction, I'm just going to type -0.75. X minus 6. All right, when I look at my graph, it should look like the one I see here. Okay, excellent. A downward facing parabola, a downward tilting linear function. Okay. Now we're going to calculate, see that word calc right here? We're going to calculate the intersection. We're going to press second trace. We're going to choose number 5. Now, because there are two intersections, we're going to have to do this twice. So this is my first curve, so I'm going to press enter. This is my second curve, I'm going to press enter again. It's going to ask me to make a guess, and you'll see that it's giving me this solution over here. So I'm going to say, what did they say to round to? Round to nearest tenth. I'm going to say -2.1. -2.1. So I'm going to type that here, negative 2.1 with a comma. And I got to go back. I got to do this again. Second trace, intersect, number 5. But this time I'm going to go all the way over here. I want to get closer to the second intersection. See how I'm moving my arrow? Okay, there we go. Enter. Is that the second one? Yes, enter. And voila! I have my other intersection. And that looks like 2.85, which is going to round to 2.9. Ooh, I feel like I didn't check that other one carefully enough. Did I round it appropriately? Let me double check. So I'm going to arrow back over here towards that intersection. Yeah, I did. Okay. And click submit. All right. So for this one here that says function equality using technology, you might need to type these in if you can clearly see that they are non-integer values. Type those into your calculator. All right, now we've got some old information here. We talked about rational and irrational numbers. If you're not sure if a square root is rational or irrational, simply type it in your graphing calculator in the math menu right here. Square root of 53. If it's a perfect square, you'll see an integer. If it's irrational, you'll see this wacky decimal. So we're going to say it's irrational, and that's because 53 is not a perfect square. So we have a square root question, but the square root of 53 is a non-perfect square. Let's try another one. I think I just did this one. Square root of non-perfect square. Okay, next problem. Okay, now this is not a square root question. Let's see. 528,176. 817681. Oh, okay, so I do see a pattern here. 8176, 8176, 8176. So there is a pattern. It's the same every time after the 2. So it is rational because it is a decimal that repeats. Decimal that repeats. Same repeat every time. Ooh, what's this? 383888 3888 38888. Now that's a pattern. But is it the same every time? No. So this is irrational because it is a decimal that does not repeat the same pattern. Decimal that does not repeat the same pattern. All right, last one. Now, it's been a while since we've done consecutive integer questions. So let me take a screenshot of this. And let's work this out together on another screen here. Okay. When an integer is subtracted from 7 times the next consecutive integer, so remember we had this, right? The difference is 13. Okay, so because it's next consecutive, it's a +1. So when an integer, that's this one, is subtracted from, that means this. 7 times, that means this. And the next consecutive integer, that means this. The difference is 13. All right, 7n plus 7 minus n equals 13. 6n plus 7 equals 13. 6n minus 7 divided by 6 divided by 6. So find the value of the greater integer. Well, this is the smaller one. So the greater one would be 1 plus 1, or 2. Okay, pause if you need to see that a bit longer. So 2. Sweet. Let's try this one more time. When an integer is subtracted, let's see, next screen. When an integer is subtracted from 4 times the next consecutive integer, the difference is -11. So, same issue as before, next consecutive. An integer is subtracted from, that means this, 4 times, that means this. The next integer, that means this. Well, this is the exact same problem as last time. different digits. Subtract 4 from each side. Divide both sides by 3. Find the value of the greater integer. Well, -5 plus 1 would be -4. So I'm going to type that in here. Let's see if I can't get a different looking question next time. Ah, yeah, here's a good one. Okay. The perimeter of a rectangle. Well, I know this already. The perimeter of a rectangle is 198 feet. That goes here. The length and find the length and the width. If the length is, that means this, an integer, and the width is 3 times the next consecutive integer. All right, so now I have substitutes for L and W. So 198 is equal to 2 L's, which is N, and 2 W's, which is, 3N plus 1. That's parentheses inside parentheses, but we got this. 198 equals 2N plus 2. Let's take care of this first. 3N plus 3. Then we'll take care of this second. Alright, 198 equals 8N plus 6. Subtract 6, subtract 6. Divide by 8, divide by 8. 20. This goes in with 16 with 3 left over, 4. 24 is N. So the length is 24, and the width is 3 times 24 plus 1. Or the width is 3 times 25, which is 75. Alright, we got this. The length is 24. The width is 75. Go back, pause the video if you need to see that again. Good luck. You got this.